Today we're going to continue talking about magnetic fields, and we're going to focus mainly on the field potential. So studying how strong that is, how it affects electricity in particular. So in 1820, Hans Christian Ørsted, when he was investigating the relationship between electricity and magnetism, and he noticed that when he had a compass sitting next to a current flowing through a piece of wire, he noticed that the needle on that compass would deflect and move around. It would point away from the North Pole when he connected the wire to the battery in a certain way, and then when he disconnected it, he noticed that the needle went back to its original position. So he deduced because of this that electricity or electric current traveling through a piece of wire actually produces a magnetic field. And he could observe that in the compass needle. So here we have kind of a setup of what he observed. So we have our wire carrying a current flowing through our, flowing over a compass, and it produces actually a magnetic field around that piece of wire. So current produces a magnetic field, is what he discovered. And we can observe the direction of that field by just adjusting which way the current is flowing. So it was experimentally observed that the direction of the magnetic field is going to depend on the direction of the current. So if current flows one way, the north is this way, the south is this way. When you switch the current, it switches the poles. So we can use something called the right-hand rule to determine the direction of our magnetic field. So we're going to take our right hand, so not your left, has to be your right, and your thumb is going to point in the direction of the current, and your fingers curl in the direction of the field. So if we're looking at this picture, our thumb is pointing upwards, and our fingers curl around kind of counterclockwise. And so that would be the direction of our field. It would be counterclockwise around that piece of wire. And we label, remember, a magnetic field with a B. So a use of using electricity to generate a magnetic field is in something called an electromagnet. So an electromagnet is a device where you have a coil of wire wrapped around an iron core, and you pass current through it, and as the current flows, it produces that magnetic field. And so a lot of people in industry, especially like junkyards, use electromagnets in their field. So you turn on the current, flows through, creates an electromagnet on the end of this crane. It can pick up metal, move it somewhere else, and then when you turn off the electricity, it causes the electromagnet to become demagnetized, and the material can drop. And so that's what an electromagnet is. And we see them all the time, so anything that has an electric motor, like a fan or a toy car, have electromagnets in them. Speakers contain electromagnets. We'll talk more about speakers when we talk about sound. So how do we know the direction of our magnetic field? So remember, the magnetic field is looping around a wire. And so it depends on how the current is flowing and how our wire is oriented in space. So we use arrows to show the direction of the magnetic field. So if our magnetic field is left or right, we use a left or right arrow. Our magnetic field can also be up and down. We would use up and down arrows. But how do we show the third dimension? We don't live in a flat world. So how do we show that the magnetic field would be coming out towards us or into our paper or behind us? So how do we represent that third dimension? And so we represent the third dimension kind of if you picture an arrow. So one end of the arrow, you would have a point, a dot, and on the other end of the arrow, if you're looking at the feathers of it, it would create an X. And so if our magnetic field is going into the page, we would see the back of the arrow, or the X's. So we use X's to represent the field going into the page. If our field is coming out of the page, we would represent it with circles or dots. So coming out towards us. just like you would see the head of the arrow as a point. So X's mean the magnetic field is going into the page or curling this way. And our magnetic field is out of the page, it would be curling this way. So here is an example. If we have a current flowing through a loop of wire, we want to point our thumb in the direction of the current, so upwards, and our fingers would curl in the direction of the field. So my fingers are curling out towards me, so we would represent inside our circle, our magnetic field would be coming out. And if we were to continue curling around, if we're going to the outside of the circle, we should see X's out there, because at that point the magnetic field would be curling back into the page. No matter where you are going on that circle, okay, it would be curling into the page. But in the middle it curls outwards. So remember, right hand rule, point your thumb in the direction of the current, and your fingers curve in the direction of the field. So let's try some examples. So which diagram shows the magnetic field in red around a current carrying wire in blue? So blue is, the arrow is representing our thumb. So our thumb needs to be pointing to the right. And my fingers are going to curl in the direction of the field. So on top of my wire, my fingers are coming out at me. So remember, out of the board should be dots. And if I continue curling around, they would curl back into the page on the bottom. So my answer should be B on this one. Or sorry, D. So out on the top and in on the bottom. Okay, let's try another one. So here we have a current, which is represented in blue as the X, and red is the direction of the field. So my thumb should be an X. So remember, X means into the page. So my thumb should be pointing inwards. My fingers are going to curl in the direction of the field. So my fingers are curling from right to left around my wire. So my answer should be C. So my thumb is pointing inwards, my fingers curve to the right, and then back around on the other side. So C for number 2. So why don't you pause the video and see if you can do this one on your own. So which diagram shows the magnetic field in black around a current carrying wire in red? So my thumb should point in the direction of the red arrow, so upwards, and my fingers are going to curve in the direction of the field. So on the left side of my arrow, they'll be pointing out at me, so dots. On the other side of the arrow, they would point in. So my answer should be C on number 3. Okay, let's try this example. Which diagram shows a magnetic field inside and outside of a current carrying loop? So again, my thumb should be pointing in the direction of the wire in blue, so pointing to the left. And my fingers are going to curve. So on the outside of my loop, so if I'm trying to grab that loop, it would be going into the board first, so X is on the outside. And as I come into the circle, my fingers would be pointing out towards myself. So the answer should be B on this one. So thumb in the direction of the current, I go into the board first, and like I'm going to grab the loop, and then on the inside my fingers would curve outwards. Okay, let's try another one. So which diagram shows the magnetic field around a current carrying wire? So my wire is being represented by the black dot, so it should be pointing out at me. My thumb should be pointing outwards, so my fingers are going to curve in the direction of the field. So I'd be curving to the left first and then back around to the right. So my answer should be B on this one. Okay, let's try another one. So which diagram shows the magnetic field around a current carrying wire? So my wire is red, my thumb should be pointing to the left. My fingers are going to curve into the board first on the top, so X is on the top, and then on the bottom they should curve outwards. So my answer should be C on this one. Okay, another one, my thumb in the direction of the current, so my thumb should be pointing to the right, And on the outside of the loop, my fingers are going to come outwards at me, so dots on the outside. And then inside, my fingers will curve back into the board. So it should be D on this one. And last example. So which diagram shows the magnetic field around a current carrying wire? That's correct. So my thumb for A should be pointing upwards. My fingers would curve out and then in, so A seems correct. On B, my fingers would be curving in on the left, but then out, so that is incorrect. And then also making C and D also incorrect. So the answer should be A on this one.